All right, so we're ready for Chapter 2, Lesson 4. Chapter 2, Lesson 4 is one of those lessons. It's really pretty easy if you'll just learn the steps, but I have some students, they'll take a really long time to adapt to accepting this. I'm going to suggest you start cross-reducing as soon as you possibly can and continue that on because this will help you from sixth grade math for the rest of the year all the way through junior high and high school. Even when you get into some classes like chemistry, when you have to balance equations in chemistry, cross reducing is going to be key to helping and making your life a lot easier. So when we're doing cross reducing, we're going to cross reduce everything we possibly can. Now, what I mean by that is when I have two fractions or even three or four fractions, it's all multiplication. I can have a numerator and a denominator that can be cross reduced, which means, once again, reducing, dividing by a smaller number that will go into both. If you find that greatest common factor and divide top and bottom by it, it's going to make your life a lot easier. They could be in the opposite direction. They could be diagonal in the other way. Or sometimes you're going to see that the book, I learned, things like that, they're going to try to trick you and they're going to give you a fraction that's not reduced in your problem that is stacked together like 3/21. And you can reduce by the greatest common factor of 3 and 21, which is 3. So once I cross reduce everything that I possibly can, then I'm going to end up with this basic multiplication problem. And we go back to our multiplication of fraction questions. Can I multiply fractions? Yes, absolutely. How do I do it? I'm going to multiply across. Therefore, when I get to the end, I should have everything already reduced as low as I possibly can, and I shouldn't have to reduce anymore. Simplifying, I might, because I might end up with that top heavy, right? That improper fraction. So if it's top heavy, then I have to simplify and convert it, into a mixed number. So follow along as I'm going through it. Make sure you're focused and paying attention, right? If you're focused and paying attention, once again, this is really an easy lesson to learn, and it's going to help you so much as we go throughout the year, but also as you move forward in math. So they give you the setup of this math question, and you can see the basic math question here. They're going back to what we first started with just straight multiplication of fractions. Can I multiply fractions? Yes. What do? I multiply across. So I take 2 times 7, which is 14, and 5 times 10, which is 50. Now, once I've created that, then I have to ask, well, what will go into both of those? And since they are both even, I automatically know 2 will. So if I have 14/50ths that I'm going to reduce by 2, once again, dividing top and bottom by the exact same number, I'm going to divide both of those by 2. 2 will go into 14 7 times, and 2 will go into 50 25 times. So then that's reduced as far as I can go, and that's going to give me my answer here. The next half of the page is showing you what we're going to work on, and this is my ultimate goal when it comes to multiplying fractions for you, is that everyone will cross-reduce. Show me how they're cross-reducing, what they're doing, and truly understand this concept, because as I'm saying, it's going to make your life a lot easier. So when I see what I'm multiplying here, then notice in the blue they're saying I should be able to notice by now that those are both even numbers. And if they're both even numbers, then I know 2 will go into both of them. So instead of multiplying across and everything, I'm going to go ahead and I'm going to cross-reduce. Reducing, once again, is dividing both numbers by the exact same number. Greatest common factor, if you can figure out what that is, which does happen to be 2 on those. So when I look at dividing 2 by 2, I end up with 1. And then I divide 10 by 2, and that's going to give me 5. So when I cross-reduce, it's just that division process inside of my math problem. I would do it here before I multiply them straight across. And then I'm left with 1 times 7 and 5 times 5. So you don't have to rewrite these multiple times as you're going through them. I would start here, cross-reduce, multiply what's left. When I multiply across then, I end up with 7/25, which is exactly what we had before. So as I put up here, there's more than one way to do a math problem. There's nothing wrong with the basic multiply across and reduce at the end. What I generally have is a lot of students either forget to reduce or they reduce once and think they're done, but they didn't reduce by the greatest common factor. So if I work through this and cross multiply, I end up with much smaller numbers and my life becomes much easier as a mathematician. So my original problem is 5/8 multiplied by 14/15 on this one. And when I look at it, we can see that we're already cross-reducing in the book, and they want you to figure out what you're cross-reducing by. Well, if I reduce by something with my 5 and end up with 1, that should tell me why I multiply, or excuse me, reduced by 5, because 5 goes into 5 one time. And they both end with 5, so I know since they both end with 5, my greatest common factor on that one at least is going to be 5. But 5 would definitely go into it. So I'm going to take 5 divided by 5. That's where that 1 came from. And then I'm going to come over, I'm going to take 15 divided by 5. Now notice the book crosses these out every time before they write out what it is. I would suggest the exact same thing, because if you don't, you might end up with 2, 3 layers of numbers, and then you lose track of where it is that you are supposed to be working with when you get to your final numbers. So I would cross those out just like the book is showing you. And therefore I end up with 5 divided by 5, which is the 1, and 15 divided by 5, which is 3. But hopefully you noticed as I was talking that these can also be reduced. They're both even. And what will go into both even numbers? 2. Is it my greatest common factor? Well, if I look at 14 in my mind and I have 1 and 14, 2 and 7, yeah, 2 is my greatest common factor. So I'm going to reduce both of those by 2. That's what this second step is showing you. So now I'm going to reduce both of these by 2. 2 will go into 8. Notice I cross it out when I say that, and I put the answer. And 2 will go into 14. I cross it out, and I put its answer. So 2 will go into 14 7 times. 2 will go into 8 4 times. I look around. Is there anything else I can cross reduce? No. Now they once again are building this in 3 different steps. You don't have to do that. You can do it all in one, which I'll show you in our practice problems. But what I'm left with is just a 1, a 7 in my numerators, a 4 and a 3 in my denominators, and now I have multiplication of fractions. Can I multiply fractions? Yes. What do? I multiply across. 1 times 7 is 7. 4 times 3 is 12. It can't be reduced any further. I've done it all. So that would be my final answer of 7/12. All right. Now, as I'm saying here, and I've already said on the video, this is going to make your life much easier if you just say, all right, so if I take this simple step at the beginning, it makes my life easier at the end, and I know that it's going to apply for the rest of the year because Mr. Barker said it is, right? But it's also going to carry on throughout all of your high school classes. Cross-reducing is a key and vital concept. Some students just don't want to take the time to do that. They want to get those big answers. Well, when you get to like 3 answer numerator or digit numerators and 4 or 5 digit denominators, trying to reduce those is going to become even more difficult. So if we learn to cross reduce, we're going to be okay. So when I look at 3/8 and 2/9, I like to start and see, well, can these be reduced first? And no, 3 does not go into 8, 2 does not go into 9. So then I look across. So when I say across, I'm talking diagonally, not the multiplying straight across. So I've looped them here for you to see what I'm talking about. I have my 8 and my 2. I have my 3 and my 9. Both sets can be cross-reduced. So I'm going to ask myself, well, what will go into 3 and 9? What is the largest number? Well, 3 is a prime number, and 3 will go into 9, so I'm going to reduce by 3s. When I reduce by 3s, or excuse me, when I go to the next one then, I have 8 and 2, or 2 and 8. 2 is a prime number, but 8 is also even, so I know 2 will go into both of those. So my greatest common factor is going to be 2. Notice I put in here what I'm actually saying. Don't let the idea of greatest common factor confuse you. Just remember factors are smaller numbers, pieces that will go into. But what I'm asking is what will go into both 3 and 9? What will go into both 2 and 8? When I know what I'm going to reduce by, then I just have to do the division. Notice I've already crossed both of these out for you. Make sure you do that so you can keep track of what you have left. I'm reducing by 3. So 3 goes into 3 how many times? 1 time. And 3 goes into 9 how many times? 3 times. So I know I have my 1, I have my 3. Once again, diagonally, I'm going to reduce by the 2, and I'm going across them out as I go through. So 2 will go into 2 1 time, and 2 will go into 8 4 times. Whatever I have left should be reduced as far as it will go. So then I just have my multiplication of fractions. Can I multiply fractions? Yes. What do? I multiply across. So 1 times 1 is 1. 4 times 3 is 12. That's as low as it can possibly go. That is a reduced fraction. We're going to do the same thing on B here. Now, the nice thing about these type of problems is when I have the same number diagonally, I don't have to go through all that thinking process. Well, what do I have to go? It's the same number, right? And we talked about fractions before. If I have the same number in numerator and denominator, it's just equal to 1. Those automatically are going to cross out and become 1. But our thinking questions, once again, going diagonally because they can't be reduced up and down. I'm going to ask what will go into 4 and 12. I'm going to ask what will go into 7 and 7. What will go into my 4 and 12? What will go, or is 4, and what will go into my 7 and 7? Well, 7, because it's the same number. So when I look at 4 divided by 4, it's automatically going to be 1. And 4 will go into 12. I cross out the original numbers when I'm doing my division, and I write down what I ended up with. So once again, 4 goes into 4 one time, and 4 goes into 12 3 times. Okay? And then I said with 7 and 7, they're the same number, so those just are going to automatically become 1s. Now, one of the things that you can do just to make sure you're showing your work and you are understanding what you're doing is go ahead and show that you're dividing by your 7s. If you understand the concept that the same number in numerator and denominator cross out and become 1s, I am fine with you just crossing them out and showing me your 1s. I need to see if they aren't the same number, what you're reducing by, so I know how you're doing it, just in case you make some mistakes, then I can find your error in your work. Remember, I always require you to show your work. So now I'm left with the lowest numbers I can go. I'm left with multiplication of fractions. Can I multiply fractions? Yes. What do? Multiply across. 1 times 1 is 1. 1 times 3 is 3. Pretty simple? I'm hoping it's pretty simple. So now we're going to just think about what we're learning and what we're doing. This question is, explain why you cannot simplify before multiplying when you're finding 3/5 times 6/7. So when I look at that, and if we understand the concept of cross-reducing, why can't I cross-reduce? Why can't I simplify, as the book says, before I multiply across? Well, the reason is there's nothing that I can, right? You cannot simplify because there isn't a common factor between either diagonal or stacked set. So my numerators and denominators, there's nothing to cross-reduce. This would just be a basic multiplication of fractions. I'd multiply across, and that would be my answer. Number 2 says, compare these strategies. What if you divide by a common factor other than the greatest common factor before you multiplied? First question. How would that affect your answer? Second question. So if I don't reduce or cross-reduce or simplify with my greatest common factor, then what ends up happening is I might have to reduce later, right? So if I see, like 9 and 27, and I think, well, 3 will go into 9 and 27, and I cross-reduce those, and I end up with 3 and 9. If I don't then reduce that 3 and 9, then I end up with, at the end, having to reduce. And that's okay, right? We can do that. We can get to an answer that we realize, I didn't cross-reduce enough inside my math problem, so I'm going to go ahead and reduce on the outside. I have to make sure that I have reduced fractions in my answer. Here's an example, though, and you might write this down in your book, just so you have an example and we understand what I'm talking about here. If I have 4 8s and I see, well, 2 will go into 4 and 8. That's a true statement because they're both even. So I reduce those and I end up with 2 and 4 because 2 goes into 4 2 times and 2 goes into 8 4 times. 4 times. I think I said 4 times. So 2 goes into 4 2 times and 2 goes into 8 4 times. But I can't leave that there because when I'm dealing with fractions, I have to have them reduce as much as possible. So I'm going to have to reduce a second time. And there's nothing wrong with that because 2 will go into 2 one time and 2 will go into 4 2 times. What we're looking at then is, well, if I don't, or if I do use my greatest common factor, then my work gets basically cut in half on that problem. Because instead of having to reduce twice, I only have to reduce once. When I can see my greatest common factor of 4 and 8, so I have 1, 4, and 2, and then I have 1, 8, 2, and 4, my greatest common factor would be the 4. I'm going to reduce by 4 instead, and 4 goes into 4 one time, and 4 goes into 8 two times. I end up with the same answer. I have to do it twice over here, I have to do it once over here. So they're just trying to get you to think, well, if I use my greatest common factor, then my steps get reduced dramatically, and it makes my life easier. All right, so once again, we're going to work through practice problems, and I want you to follow along. I want you listening and paying attention. I want you learning and getting this concept, because once again, your life's going to be so much easier if you can do this. Even our next couple lessons where we're doing division, it's going to be so much easier if you know how to cross reduce. Okay, so make sure you're filling out your book. Make sure you're understanding what we're doing. So we start out with 5, 6, and 3/10, and they're showing you that I'm going to cross reduce both ways, right? That's why they're all 4 crossed out. So I'm asking, well, what will go into 5 and 10, and what will go into 3 and 6? So when I look at my 5 and 10, as we're working through, 5 will go into 5, right? And it will go into 10 because it ends with a 0. So 5 goes into 5 once, and 5 goes into 10 twice. And then I have 3 and 6. 3 is my prime, 3 goes into 6 evenly. I'm going to reduce by my 3. So I'm showing what I'm dividing by, right? Once again, you must show your work. And if there's not enough room inside of your homework paper, that's what all those boxes are for, in the inboxes in the front. Just grab 1, grab 2, whatever you need. And you can do it on line paper if the lines help you keep yourself more organized. I'm okay with however you do it, as long as you show me your work, you understand, and you get the right answer. So I'm going to reduce by 3s. 3 goes into 3 once, and 3 goes into 6 twice. So I've reduced as much as I can. Now I'm going to multiply across, because that's how we multiply. 1 times 1 is 1, and 2 times 2 is 4. So I know my final answer is 1/4. Now we're going to go through all the steps on our paper. All right, so I can't reduce anything that's stacked, right? 3/4 and 5/9, they're as simplified as possible. So then I look diagonally. Well, when I look diagonally, I'm going to say, well, I know 3 will go into 3 and 9, greatest common factor. So I'm going to take 3 divided by 3, and I'm going to get 1. Once again, cross these out and show me what you're reducing by. And then 3 will go into 9 3 times. 4 and 5. I can't reduce those, can I? So I only have to do it once. So what I'm left with is I'm going to multiply across. 1 times 5 gives me a numerator of 5, and 4 times 3 gives me a denominator of 12. Mental check, can that be reduced? No, 5 is a prime number, and 5 doesn't go into 12. So I know I did the best I could, and I end up with 5/12. So 2/3 and 9/10. Quick check, the stacked fractions, they're simplified as much as possible. So now I want to see diagonally, can I reduce? I can cross reduce both times, right? So I'm going to cross reduce my 2 and my 10. What will go into 2 and 10 evenly? 2 is my prime, and 10 is even, so I'm going to reduce by 2's. Show me what you're reducing by. Once again, reducing, dividing both top and bottom by the same number. 2 will go into 2 once, and 2 will go into 10 5 times. 3 and 9, 3 is a prime, 3 will go into 9 evenly, so I know I'm going to reduce both by 3. I'm going to show that. And then I just cross them out because I'm going to reduce. So 3 will go into 3 1 time, and 3 will go into 9 3 times. What I'm left with is multiplying across. 1 times 3 gives me 3 as my numerator. 1 times 5 gives me 5 as my denominator. 3/5 is my final answer. All right? Hopefully this is pretty easy. It's designed to be easy, and it's really designed to build on to yesterday's lesson. So then we get story problems, and once again, please don't let the story problems confuse you. Now on the front of your first packet that we gave you, we highlighted the word of, and then we wrote a little note under there, right? 80-some percent of the time, of means to multiply, but not always. And here they're going to try to confuse you. After a picnic, 5/12 of the cornbread is left over, of, right? So it must be multiplication. So what would I be multiplying by? There's nothing there to multiply by, is there? Because the cornbread is left, I don't know how much of the cornbread is left over. So that doesn't mean multiplication there. That just means the word of. That's what we're talking about. All right, so if I keep going, now eats 3/5 of the leftover cornbread. What fraction of the cornbread does Val eat? That of. Does that mean multiply? Well, I'm taking 3/5 of the leftover cornbread. Do I know what the leftover cornbread is? Yes. The leftover cornbread is that 5/12. So that of tells you to do what? Multiply. So I'm going to set up my math problem. I'm going to take 5/12 times 3/5. Now, what if I say, well, I want to set it up as 3/5 times 5/12? That's okay, because multiplication can work in any order. It doesn't matter which side they're on. I'm going to see if I can cross reduce. Well, I can cross reduce both ways on this one, right? I can see 5 and 5. Once again, you can show me you're reducing by 5s, but if you get it, that the same numerator and denominator equal 1, I'm fine with you not showing me that you're reducing by 5s. You just cross them both out, and they both become 1s. Or you can show me that 5 divided by 5 is 1, and 5 divided by 5 is 1. Both work. Now, what am I going to take into 3 and 12? Hopefully inside your head, you're like, well, 3, duh. I'm going to reduce by 3. So 3 will go into 3 one time, and 3 will go into 12 4 times. What am I left with? Multiplying across. 1 times 1 gives me 1 in my numerator. 4 times 1 gives me 4 in my denominator. Am I done? No, Mr. Barker, because it's a story problem. Excuse me. And I have to have a label. What is my label? Well, I go back to the end question that's actually asking the question, right? The first two are just sentences. What fraction of the cornbread? So I need to have 1/4 of the cornbread. That's my label, right? And I'm always going to find it here when it's telling me what to find. All right, so let's look at the reptile house. The reptile house at the zoo has an iguana that is 5-6 yards long. It has a Gila monster, and it's Gila, not Gila. Gila monster that is 4/5 of the length of the iguana. How long is the Gila monster? So there's an of. Does that mean to multiply? Well, 4/5 of the length of the iguana. Do I know what the length of the iguana is? Yeah, the 5-6, correct? So that does mean multiply. So that's what I'm going to do. I'm going to take 4/5. I'm going to take 5/6. Once again, any order that I want to, because it's multiplication. Addition and multiplication can always be worked in any order. I'm going to reduce both of my 5s to 1s, or show the step of dividing, reducing by 5s. 5 does go into 5 once, and 5 does go into 5 once. 4 and 6, 4 is not a prime number, and 4 will not go into 6. So their greatest common factor is they're both even, 2. So I'm going to reduce 4 and 6 each by 2. Remember, cross these big numbers out as you're working through it so you don't get lost on what you're left with. 2 goes into 4 twice, and 2 goes into 6 3 times. I'm left with the smaller numbers, so I'm going to multiply across. 1 times 2 is 2, 3 times 1 is 3. Then I have to figure out what I'm looking for. How long is the Gila monster? So I'm looking for my measurement that they give me in my math problem. Don't put it's 2/3 long. I need the measurement that's used. And when I go back, it says yards. So it's just 2/3 yards. All right, so when I'm finding the product on these, I want you to work through these, pause the video, come back and check your work when you're done. So hopefully you did what I asked. Hopefully you pause the video. You're not just watching it as I go through. So we're going to go through the same steps that we just did with the other ones, and we're going to look. I always start with my vertical ones, and there's nothing that can be reduced. So now I'm going to look diagonally. Will 1/4 be reduced? No, because 1 is as low as I can possibly go. But 3 and 6, my greatest common factor is the prime number 3. So I'm going to reduce diagonally. 3 goes into 3, cross it out 1 time. And 3 goes into 6, cross out that 6. I'm left with a 2. 2s and 4, can that be reduced? No, because they're on the same plane, right? They're either both denominators or they're both numerators. Has to be diagonal or vertical to be reduced. So I'm just going to multiply across. 1 times 1 is 1, and 4 times 2 is 8. Hopefully you got 1/8 for your answer. All right, for number 7, I am going to look to see if I can reduce. Well, I've got 2 and 10. 3 and 7. 3 doesn't go into 7, so I can't go, but I can go this way. So what would I reduce by? 2's prime, 10's even. I'm going to reduce by 2. So 2 goes, remember, show me what you're reducing by. 2 goes into 2 1 time. 2 goes into 10 5 times. If you don't show me, you're going to lose points because I want to see your work. I need to know how you're getting your answers. I'm left with 7 times 1, 5 times 3. I end up with 7/15. And then on this one, hopefully you went to Shelly's basketball team won 3/4 of their games last season. Do we know how many games they won last season? No, so that of just means of. In 1/6 of the games. What games? The 3/4 that they won, right? So that of means to multiply. So they outscore their opponents by more than 10 points. More than 10 points. So what am I doing with that 10? Nothing. Why is it there? They want to confuse you. They want to make sure that you understand what you're doing in this problem and not just picking out numbers and saying, well, I know I'm multiplying, so I'm just going to multiply everything. It's not it, right? So this 10 is just there to confuse you. Ignore it. I end up with 3/4 of 1/6. I'm going to multiply. Cross reducing my 3 and 6 by 3, which is my prime number and my greatest common factor. So 3 goes into 3 once, and 3 goes into 6 twice. 1 and 4, 1's as low as it can go, so I know that I am already reduced. Multiply across. 1 times 1 is 1, and 4 times 2 is 8. And I look at my label, it says what fraction of their games. So my label is of the games, right? Several of you are missing this point by not putting your labels on. Please make sure if it's a story problem, you put labels, right? It's maybe 5% of our story problems that don't need a label. 95% of the time it needs a label, so always go back and check. All right, so these are extra practice. You can come to me, ask for help. I'm more than happy to work through these with you if you have questions. If not, you have your assignment. It'll be on the board. Make sure you cross-reduce first. That's what this whole lesson is about. You won't always cross-reduce both ways. You will always at least cross-reduce once on this assignment. Please make sure you do it, and if you don't understand it, please come and ask.